Today we're looking at section 1.4. We're going to be looking at more definitions and postulates today, but today our new terms are going to be about angles. So first we're going to define an angle. An angle is defined as a figure that is formed by two rays. So in the last lesson we learned that a ray has an endpoint and goes on forever in one direction. An angle says that we're going to take two rays that have the same endpoint. So starting at the same endpoint, make a new ray, and that makes an angle. We have two rays that share that common endpoint. Our symbol for naming it just looks like a little angle. So just like we use a segment symbol or a line symbol, we have a symbol to let somebody know that what we're naming is an angle. When we name an angle, we want to start with the symbol and then picking a letter that is on one of the sides, one of those rays. It could be A, it could be B, it could be D. Doesn't matter, we just want to pick a letter that is on one of those rays. So I'll just pick A. Then the second letter you name must be the vertex or that common endpoint that they share, where the angle comes together or the corner of the angle. So C has to be the second letter in the name. And then pick a letter that's on the other side. So I picked A, so I don't want to pick B again, but I could pick D. Okay, so you pick a letter off of one side, pick the corner or the vertex, and then pick a letter off of the other side. The sides are the rays that make up the angle. So if you are asked to name sides, you need to make sure that you're naming them as rays. So CD is one of those rays. And the other one we could either call CB or we could call it CA because those are really the same thing. But we name the endpoint first and then go off to name one side. The vertex is that endpoint they share, so it's just a point. So if you're asked to name it, you just use the one single letter to name what point is at the corner. Any questions on naming those? There are 4 different classes of angles for their sizes. We have what's called an acute angle, which is between 0 and 90 degrees. So it's a small angle. So I remember this by acute, has the word cute in there. It's cute because it's small, like puppies and babies. Okay? So acute angles are small angles between 0 and 90. A common mistake on the test, if I ask you to define acute, students often want to just say smaller than 90. That's not quite right. It is in fact smaller than 90, but there's more to it than that. It has a border at being 0 as well. So it's between 0 and 90. We don't allow for having negative angles. Okay? So we want to make sure that we give both of those edges. It has to be between 0 and 90. We're not going to work with negative angles. A right angle is an angle that is exactly 90 degrees. Perfectly. Not 89.9, it's perfectly 90 degrees. As a symbol in a picture, you might see a little box in the corner of it, and that tells us that it's a right angle. Without that symbol, we don't assume that it is just because it looks like it. Okay, it could be 89 and our eyes can't tell the difference. An obtuse angle is between 90 and 180. So again, like acute, make sure you give both edges. It's between 90 and on up to 180. And then a straight angle is exactly 180 degrees. It's a straight line. We are not going to work with angles bigger than 180 degrees. Okay? Questions on any of those terms? Our protractor postulate has a lot of words in it, so I'm just going to draw a picture and give you the big idea of this one. The big idea is that if I have a line, A, B, and I put a point on there called O, I can then say OB is 0, OA is 180, or vice versa, and then name any angle inside of there and give it a measurement. So in our last lesson, we had the ruler postulate, which says I can take a number line and put a 0 and a 1, and I've now established a unit. Whether it's a centimeter, an inch, a mile, a meter, or whatever, I've established a unit. Our protractor postulate says we can measure angles, just like we can measure lengths. Okay, we're going to be doing our measurements in degrees. So we're working from 0 to 180. So a lot of letters, a lot of symbols. All it really says is we're allowed to measure angles. The angle addition postulate is going to be a big deal for us. We're going to use this one a lot. Pictures speak louder than words, so it'd be a good idea to draw this picture that I'm going to draw. It will be especially helpful when you're preparing for your test. Hint, hint. So, it says, if point B lies in the interior of angle AOC. So I'm going to have an angle. I'm going to call it AOC. Remember, the way we name it, that middle letter tells us the vertex. I've got a point B that's somewhere inside of here. The angle addition postulate tells us that the measure, that little m, we read as meaning measure, and that's what tells us we're talking about the size of it. So the measure or the size of AOB, that's the top one, plus the measure or the size of BOC should together make the measure of AOC, the whole thing. So just like we can add together little segments that are next to each other, we can add together little angles that are next to each other and get a bigger angle. Questions on that? The bottom gives us a special case. It says if AOC is a straight angle, then instead of just saying that AOB plus BOC is AOC, we can say specifically AOC is 180. So it says that if we're dealing with a straight line, we can be more specific. And instead of just saying it equals the bigger angle, we can say how big that angle actually happens to be. But that's just a special case. We're still taking two angles and adding them up to get a bigger angle. Okay. Questions? Congruent angles mean that they have the same measurements. Remember, congruent means two things. Same shape, so they both have to be angles, and same size. Adjacent angles are two angles that have a common vertex, so they have to have the same corner, or if we're naming them, they'd have to have the same middle letter, and a common side, so one of their sides has to match up, but no point in the interior, so no overlaps. So common angles, or adjacent angles, should be one angle that has the same side as an angle next to it, same corner, but they can't overlap each other at all. Okay? So one side matches, the corner matches, but nothing inside matches. They don't overlap, they're just right next to each other. Adjacent as a word means next to. So like I could say that my room is adjacent to Mr. Bell's room because they're next to each other. Okay, so we share a wall. So adjacent angles can share a wall. We don't share any spaces in our rooms, and adjacent angles don't share any space. They just share a wall. Okay? A bisector of an angle is a ray that divides the angle into two equal pieces. So if I put some letters in here, if XB is a bisector of angle AXC, then those two angles would be equal sizes. Okay? Questions? When we look at a picture, there are some things we can assume and other things we can't. One thing we can assume is that this is all happening flat in a piece of paper. So one assumption that we are allowed to make is that this thing is all happening in a plane. It's not supposed to be 3D. None of these things are supposed to be pointing out towards us. We can assume it's supposed to be flat on a sheet of paper. Something else that we can assume is something about points A, B, and C. What could we say about A, B, and C? Using a term from a couple lessons ago.
They're all on the same line.
They're on the same line. What was one word that?
Collinear.
Collinear. Mm-hmm. So we can say A, B, and C are collinear. They're all on the same line. We can know that because the line is actually drawn in. If the line wasn't drawn in, then we can't say, well, they look like they're in a straight line. But because that line is actually drawn in, we can know that they are. Okay. The bigger point here is what we cannot assume, because that's where students start to go wrong. So what is something that you think we would probably not be able to know, but students might often want to say?
Angle CBE is a right angle.
Students always want to call this a right angle, because it does look like it, but maybe it's 89, maybe it's 89.9. We don't know. So unless a symbol is in the picture, or unless the directions tell you it's a right angle, don't assume you have a right angle, okay? Super common thing students want to assume that we can't assume. What else might be something students would want to assume?
That angle ABD is 45 degrees.
Yeah, so students want to start assuming that like these angles are the same size. That they would both be 45. Once we've assumed that part's 90, then we might start breaking down the other half and say that both of those are 45. But we can't assume two angles are congruent just because they look like they're the same size. We have to be told that they're the same size. There's one more thing students commonly want to assume about a picture like this. And what would that be, do you think?
ABC is a straight.
We can know ABC is straight, so we know they're collinear, but it is something on that line that students want to pick.
B is like the midpoint.
Yep, students want to say that B is right in the middle, that AB and BC are the same, but we don't know that for sure. Okay, so those things that I marked in red are dangerous assumptions. Okay, those are things you don't want to assume unless directions specifically tell you, or unless there are markings in the picture to let you know that for sure. Those are things that students like to see and think that it looks like, and then proceed from there. But just because it looks like it doesn't mean it is. Okay? Okay, so in this diagram, yours has some numbers in it, I think, but mine doesn't. If yours doesn't have numbers, put them in there. They should be there. We have three different ways that we can name an angle. So we already talked in our notes about how we can name an angle with 3 letters, naming a letter off of one of the sides, then naming the vertex, then naming a letter off of the other side. Sometimes in diagrams, a number will be provided as well, so then we can name them by numbers if that's convenient. I tend to like naming by numbers if there's numbers in a picture. It's quicker than saying 3 letters. The last way that we can name an angle is in a special case where there's only one angle in the picture that has that vertex. So if we look at angle 4 up at the top there, there's only one angle happening there. So we could also call that angle C. That's the same thing. I can call it with just one letter because if I say C, you're all looking at the same place. There's only one angle there. We could name it with 3 letters. So we could call it angle like ACD, and that would be the same thing as well. Those are all okay ways to name that angle up there. If we look down at the bottom where angle D is, I can't just say, look at angle D. Because there's a lot of stuff going on there. You could all be looking at a different thing when I say look at angle D. So we can only use a single letter if there's just one angle happening at that vertex. Okay? So if I'm talking about any of the angles that are down by D as a vertex, I'd have to either use the number or I'd have to use a 3-letter name. Okay? So that's a little bit about naming them. Now our question asks us to name the vertex and the sides. What is the vertex of 4? C. Yeah. The vertex is just the point at the corner of the angle, and we name a point with just one letter. Then we're asked to name the sides. The sides are rays, named beginning with the end point, or the vertex, and then going out through one letter. So CD is one side of that angle, and the other one I could either call CB, or I could call it CA. Those are the same thing. So when you do this on your homework, different people might pick different things. So I'm going to have to be really careful in grading that I give all the possibilities. Okay? Some people may have named CB, some people may do CA. When we're naming angles, some people might use numbers. Some people might use a single letter when we're allowed to. Some people might always use 3 letters. And when you use 3 letters, sometimes you have choices. So I could call it ACD, I could also call it BCD, or DCB, or DCA. So there's a lot of different things we could call it. Okay. Questions on that? Okay, we're going to skip past these 2 and go on to the next group of problems. Okay, so we're all set now again. Name all the angles adjacent to angle 6. So adjacent, remember, means they should have the same corner. Okay, so we're looking for the same vertex. They should share one side. Okay, so they should be like next door neighbors, have one wall in common, but they don't share any common space. So when I look down at angle 6, I want its neighbors. So what's one of its neighbors?
7.
Angle 7. We could also call that EDC. Okay, if you like letters better, that's fine. If you like numbers better, that's fine. What's another one of its neighbors?
5.
Angle 5. And again, we could do BDA, and that would be fine as well. Okay, so adjacent is like its neighbors. It shares a corner, it shares a wall, but it doesn't share any space. Name 3 angles that have B as the vertex. What is one of them?
3.
Angle 3. Angle 2 has B as the vertex, and now it gets tricky. So 3 and 2 are there with their corner at B, but I said name 3.
180. Yeah.
The 180 angle. So we would name that angle CBA. Okay? Straight lines are angles. So they're easy to overlook because we don't think of them as being an angle, we think of them as being a line. But a straight line is an angle. So CBA is that 3rd angle there. Now keeping that in mind, how many angles have D as a vertex?
Angle 7.
Quadro about 4.
Okay, so I heard 4. So let's start naming them off. 7, 6, and 5.
EDA.
EDA. Any others? There are. So where are they? Where we have other angles there?
EDB.
EDB. EDB is an angle that combines angle 6 and 7 together, but it is still an angle. So then the flip side of that would also be CDA. So we have 6 angles there in total. Okay? Overlapping angles are easy to miss, just like straight angles are easy to miss, so make sure you pay attention to those. Okay? Questions? In these questions it says, state whether the angle appears to be acute, right, obtuse, or straight. So we're kind of going to trust our eyes on some of these and say whether it looks like it is acute, right, straight, or obtuse. So what does one look like it is?
Acute.
Acute. It looks like a small angle. Small angles are acute. Angle 2.
Obtuse. Right.
Do we know it's right, or does it just look like it's right?
It looks like it's right.
Not possible.
What do we know about angle 3?
Obtuse.
It's right. What do we know about 2 and 3 together?
They're straight.
They're on a straight line. How much is a straight line?
180.
180. So then if I take away the 90 of angle 3, that means angle 2 really has to be a right angle as well. So it doesn't just look like it, but it actually has to be.
Wow. Pretty good math.
EDB.
Obtuse.
That one looks obtuse. It looks pretty big. We don't know for sure, but it looks pretty big. CDB. That one looks acute. What's another name for CDB?
EDC.
BDC would work as well. What's another name for it?
6.
6. Okay, so we're looking at angle 6 there. That one looks pretty small. ADC.
Oh.
Is that yet?
Obtuse.
That one looks obtuse. It's 5 and 6 put together, so it's pretty big. ADE. Straight. And we can actually know for sure that is a straight line. That's an assumption that we can make, that when 3 points are connected in a line, that is a straight line. On these, there's two different symbols that tell us the type of answer that we're looking for. When it says M angle, it's asking us to name an angle. Okay, so to name what we would get if we would put those together. If it just says equals, it's asking for the actual size of the answer. So 6 and 7, if we put those together, we cannot call it 13. Okay, that's tempting to do, but there's no 13s in the picture. So when we put together 6 and 7, we can no longer call them by numbers. We need to name them with letters. So what would I call it if I put together 6 and 7? BBB. What about if I put together 5 and 6? What could I call that? CDA. Now this is when we're just as equals and not measure angles. So here I want to know, what does it actually equal if I put together angles 2 and 3? 180 degrees. If DB as a ray bisects angle CDA, then what would be true? What does it mean to bisect?
Go directly in the middle.
Go directly in the middle. So what would be true about something in that picture then?
Angle 6 and 5 would be equal.
Angle 6 and angle 5 would be congruent to each other. Okay. So a bisector makes congruent pieces. So if we're bisecting a segment, we get equal segments. Here we're bisecting an angle, so we get some equal angles. Okay. Questions? Last group of problems. You're supposed to be given a piece of information here that I don't think copied on through. There should be a 50 in that segment there. So now we want to say whether or not we can for sure reach this conclusion. Not assuming, but whether we can know for sure. Can we know that the measure or size of angle FOB is 50? Yes, because that's the one I just told you to fill in. Can we know for sure that angle AOC is 90?
Yes.
For sure?
No.
Not for sure. It looks like it, but that's one of those dangerous assumptions.
There's no square thing.
There's no little square in the corner. Can we know that DOC is 180?
No.
That's one of our safe assumptions, that when 3 points are connected with a line, that it is in fact a straight line. Can we know that OA and OB are the same size?
No.
No. It looks like O is right in the middle of everything, but we're not told that it is. Can we know that AOC and BOC are the same size? This one and this one. Can we know those are the same size?
No.
If they were the same size, they would both be 90,
Yes.
but we don't know that they're 90. They could be 89 and 91. So we can't know they're exactly the same size. We don't know we have any right angles in this picture. Can we know that AOF is 130?
Yes.
That we can know. We know this whole thing is 180, so we can know this part of it must be 130 to go together with the 50. Questions on any of those? Last group, my formatting got really messed up here. So looking at your sheet will be helpful because looking at the board is not.
That's right.
Apparently the Mac didn't like the formatting that I had before. So points E, O, and F are collinear.
Yes.
Yes. When we connect them with a straight line, we can assume that it is in fact a straight line. Point C is in the interior of, is it AOF? Yeah, point C is in the interior of AOF. So interior just means somewhere inside. So if AOF is here and C is inside of that angle, then we say it's in the interior. The next one on your sheet says AOE and AOD are adjacent angles.
No.
No, they meet two of the criteria but not the third. They do share a vertex at O. They share a side or a wall at OA, but they overlap each other. They share some space, so they are not adjacent. AOB is a straight angle. We can assume that when it's connected with a straight line that it is in fact a straight line. And rays OA and OB are opposite rays. That is true. In our last lesson, we defined opposite rays to be starting at the same place and together making a full line. So together they would make that line AB. Okay? Okay, your homework on your sheet is right. Up here, this is wrong. It shouldn't be including 25, but that's taken care of on your sheet. Okay? This homework is due tomorrow.